So in our last video, when we talked about simplifying radicals, the purpose of that is because now we're actually going to apply it to solving quadratic equations. So one way of solving a quadratic equation, which is really convenient, is if it's in vertex form, as you guys can see below, I can just kind of undo all the operations like I would in a linear equation and get x by itself. So looking at A, excuse me, I cannot get that minus 3 free because it's trapped by this 2, that square. Well, what undoes a square is simply a square root. So I can square root both sides. And so I'm left with x minus 3, and the square root of 64 is positive or negative 8. Remember I talked about that in the beginning of the first video of this unit? That the square root of a number technically has 2 answers. So I'm going to get 2 answers here as well. So then I'm going to go ahead and add 3 to both sides. And so here's how I'll get my 2 answers. I'll take the positive value of 8, so 8 plus 3, that gives me 11. Now I'll also take the negative. So negative 8 plus 3 is negative 5. So those are my answers. Looking at B, same concept, but I don't want to start with the square root yet. I'll actually go ahead and start with subtracting 7 to both sides. So then I'm left with y plus 5 squared is equal to 21. Now I'm going to worry about square rooting to cancel out that 2, square root 21. And so I'm left with y plus 5 is equal to the positive or negative value of the square root of 21. Now, I cannot simplify the square root of 21. There's no perfect square that goes into it. It's broken down to prime numbers 7 and 3. That doesn't go any further. So then what I'll do next is I'll subtract 5 to both sides. And I get that y is equal to positive or negative square root of 21 minus 5. And that actually is my answer. I could leave it like that unless I wanted decimal values. So let's say I actually wanted you to round to the nearest 10th, let's say. So if I wanted that to happen, let's just look at what that would look like. So the square root of 21 is approximately 4.6. So that's positive or negative 4.6, and then I would add 5 to that. So then my 2 answers might be, let's see, my positive, oh, wait, I did plus 5, that should be minus. So I just realized I did that wrong, so that'd be minus 5. Okay, so then my 2 y values would be negative 0.4 approximately, or negative 9.6. Okay, so let's look at now C. So why don't you guys try C if you're starting to get the hang of it. So the first thing you would do is add 5 to both sides. And then I would have x minus 9 squared is equal to 25. And then I would go ahead to get rid of that 2. I'd square root both sides. And so that gives me x minus 9 is equal to, remember, positive or negative 25. And then I would add 9, and I'm going to get 2 different answers. So 25 plus 9 is going to give me 34. Or negative 25 plus 9 is negative 16. Now you might also see examples like D and E. Those are a lot, I feel like, quicker, easier to do. So how do I get x by itself in D? I would just square root both sides, and x is equal to positive or negative 11. That was easy. And then in E, I would have to first divide both sides by 4. So then I would get x squared is equal to 25, and we know that the square root of 25 is positive or negative 5. So you've got some practice problems below. Try numbers 1 through 3 on your own, and then check back with the video. All right, so for number 1, I didn't really exactly leave myself a whole lot of room. I'm sorry, let me see. I just want to see if I made a better slide really quick. Nope. Oh, wait. Let's see. Ah, I did. Okay, sorry. I'm losing it. Okay, so in number 1, you would need to start by adding 3 to both sides. And so you're left with x minus 8 squared is equal to 13. Then you would want to go ahead and square root both sides, and you're left with x minus 8 is equal to positive or negative square root of 13. And I can't simplify that at all. So then I would go ahead and add 8 to both sides, and so your answer could be positive or negative square root of 13 plus 8. For number 2, you would need to start by square rooting both sides, which is awesome. It works out nicely. That leaves me with x plus 6 is equal to positive or negative 9. Go ahead and subtract 6 to both sides. And 9 minus 6 is 3. And then negative 9 minus 6 is negative 15. So those are your 2 answers. And then number 3. Whoops. Number 3. Ooh, I like this one. Hopefully you didn't think you needed to distribute the 4. I would actually start this one. I like this one. I would actually divide both sides by 4 first. And so then you're left with m plus 1 squared is equal to 9. And then you're going to square root both sides, and you're left with m plus 1 is equal to positive or negative 3. And then you'll subtract 1, right, from both sides. And so 3 minus 1 is 2, but then negative 3 minus 1 is negative 4. And then finally, application problems. Same concept, we're just looking at it as a word problem. So we talked about examples like this, but we graphed them. So during an experiment, a ball is dropped from a height of 205 feet. They give you the following formula that can be used to approximate the number of seconds t it takes the ball to reach the height of h from an initial height of h2 in feet. So find the time it takes the ball to reach the ground. So we actually have to complete the rest of this, or this formula here that they give us. So we don't know the height, but they say that the initial height, which is that h2, subscript 2, I should say, I'm going to replace that with 205. Okay, and if I'm trying to figure out when it's going to reach the ground, well, then that tells me my height. If it's on the ground, what's the height? Hopefully you're saying, well, it's 0. So what I'm going to do is I'm going to take, I'm going to plug in 0 for height, and now I can solve for t. I know it doesn't look like it, but we can do that. We can subtract 205 to both sides. And so now I kind of ran out of room, so I'm going to go over here. I get negative 205 is equal to negative 16 t squared. And then I'll divide both sides by negative 16. So that cancels. And that's going to leave me with approximately 12.8125. I'm just going to leave it at 8.1, or 0.81, sorry, is equal to t squared. And then I will square root that. So I'm going to do this in a different color just because I'm getting close to the edge here. So I'll square root. Now, remember that we always get 2 values, right, when we square root, but time can't be negative. So, and I'm going to approximate this, 3.6 seconds. So that's how long it takes for it to go up and then down. And so if we had been graphing this, just as like a side note, you don't have to write this or draw this, but our graph would have looked like this, and we would have had done all this work just to figure out that it's going to go approximately 3.6 seconds before it hits the ground. Or we throw it onto Desmos. But just know that we're doing that same thing that we just did in the first part of the unit. Now we're just calculating it. So what I'd like you to do is try the next one on your own and see if you guys can create an equation and figure out how long it'll take to hit the ground. So in this one, it says find the time it takes the ball to reach the ground if it is dropped from half the height as the one described above. Okay, so I'm still using that formula, h equals negative 16t squared, except for it's not going to start at 205. It's actually going to start at 102.5. Okay, now we want to figure out when is it going to hit the ground. So, all right, that means the height's 0. And negative 16t squared plus 102.5. So you would have subtracted 102 to both sides. Subtract 102.5. Get negative 102.5 equals negative 16t squared. And I'm running out of room, so I'm going to go over here. So when I divide both sides by negative 16, I get approximately 6.406. Okay, equals t squared. And then when you square root, again, we get two answers, a negative and a positive, but we can only take the positive because it's time, and time cannot be negative. And you get approximately 2.5 seconds.